All right, hello and happy Valentine's Day. That's when I'm recording this. I want to show us sort of a cool limit that I remember surprising me when I was a student. I didn't quite believe it. And so it says if we take the square root of 9x squared plus x, and then we subtract 3x, then surprisingly we get a weird number. We actually get the number 1/6. So where is that coming from and what's going on? Well, I guess when we look at this, if we plug in infinity, well, the first term is going to be really, really big, right? If we plug in 1,000,000, then this first term is roughly going to be about 3,000,000. And then when we subtract the second term, it's also roughly going to be 3,000,000. But the first term is a little bit bigger, right? Notice if it was just the square root of 9x squared, that would just be 3x. And so what we've got is we've got something that's a little bit bigger than 3x, and then we're subtracting off 3x. And the question is, what happens for really, really, really big numbers? So the way we're going to approach doing this is the same trick that we used to compute other limits with square roots, and that was multiplying by the conjugate. And so what we're going to do, and it's a little bit messy, but we're going to multiply our expression by the same thing, but we're going to switch that sign. So instead of having minus 3x, we're going to do plus 3x. We're going to keep everything else the same. And since we don't want to change our expression, we don't want to change our function, let's keep it the same. Let's do top and bottom the same. And that magic thing that happens when we multiply by the conjugate is that when we FOIL it out, our middle terms are going to cancel. And so what's left is just going to be 9x squared plus x. That's going to be the square root times itself. And then this last term, which is, maybe I'll circle it, and that last term is going to be 9x squared, which is going to be gotten by squaring the last term and subtracting. And so that's great. Let me switch to a different color. And then on the bottom, we still have that same thing that we have here. And so we look at it, we say, well, we still can't really simplify. We can't plug in infinity at least, but I can cancel the 9x squared, so it's cancel. And then I can say that now I've got x over this rather messy looking square root. And this is going to be the thing we're going to focus on. So let me just copy and paste. So there is our limit that we want to compute. And if I think about this, well, morally, our numerator is just x. And on the bottom, if I ask you a question, let me write this down. What is the degree? Put this in quotes because it's not exactly what I mean, but what is the degree of the denominator? If I look at the denominator, I say, well, the biggest term I see is this x squared. But then I'm taking a square root of it. And so the square root, if I do square root and then if I square something and then take the square root, that's like not doing anything. So I look at this and I kind of say, well, this is maybe like degree 1. And this is also degree 1. So let's sort of clear that up. And that's good because our denominator also has degree 1 as well. And so if I look at this, I can sort of say that if x is really large, then this is going to be approximately equal to, so in terms of the limit, it's actually going to be equal to, it's just going to be the same as doing x over, well, I don't really need that little x term there, right? That's going to be so insignificant as compared to the square roots of 9x squared. And then I add 3x. And then if I simplify everything, I'm just going to get x over 3x plus 3x, which is going to be x over 6x. And now we can see that the answer is going to be 1/6. So at least we got that number. At least we got the number 1/6. And if all of that sort of seemed reasonable, then that's great. That's all I would sort of be looking for, and I think that that's sort of great intuition. The only thing is that if you want to see maybe a little bit more, completely rigorous, doing all the algebraic steps, then keep watching the video. Otherwise, go and enjoy the rest of your day. But I'm just going to do a few more steps to sort of show you what we could be doing. So basically what I'll do is I'll divide top and bottom by x. So if I do that, then I'll be having the limit as x goes to infinity of, let's see, that's going to cancel, so we get 1 on the top. And then on the bottom, what we're going to get, well, I guess we take the square root and we divide that by x. And here that's just going to be 3. And then what's going to happen? Well, I can look at that and I can say, well, look, x is the same as the square root of x squared. And so what I can do is I can sort of bring this under the square root symbol. If I sort of make that an x squared, like double check, let's see that if I simplified this fraction, I'd be doing square root of x squared, and that's going to be the same as x. And so now let's add in the 3. And now finally, I just want to simplify that expression inside here. So we're going to have the square root of 9 plus 1 over x. And now I think we're finally done. So now we can see as x goes to infinity, this 1 over x is going to go to 0. And we're going to be left with 1 over the square root of 9 plus 3, which is going to be 1/6. So that's us getting our answer in a couple different ways. If you have questions about this, send me an email, leave a comment on the video, and see you next time. Thanks.